Hello everyone, welcome to another video of Advanced Mathematics of Class 9, and today we are going to start exercise 6.2 of sequence and series. So we are going to start off with question number 1 and we are going to do one sum of each type. So let's start with question number 1 and I am going to do Roman 5 of question number 1. So let's see what is the question. It is said that choose the arithmetic progression from the following sequences. So a sequence will be given and you have to tell which of these is an arithmetic progression. So let's check this out. In question number 5, it is the terms given are 1 minus 2x, 1 plus x, 1, 1 minus x, minus 1 minus 2 x, and so on. So you have to tell whether this is an arithmetic, an AP or not. So what we do here, if we have to prove that a given sequence is in AP, we have to show that the difference between every two consecutive terms is same. That means they have a common difference. So let's try and see whether they have a common difference or not. So here what we will do, we will subtract the second term from first term. That means T2 minus T1. So T2 is 1 plus x and we will subtract 1 minus 2x from this, and what we get is 1 plus x minus 1 plus 2x. So it is 1 cancels out, it is thrice x. Thrice x is the common difference. Now we try to find the difference between these two. So it is T3 minus T2, and here we get 1 minus 1 plus x. So it is 1 minus 1 minus x. So 1 cancels, minus x. So here the difference between the first two terms is 3x, and the difference between the second two terms, second term and the third term, is minus x. So as these differences are not the same, that means they do not have a common difference. So therefore the terms do not have sequence do not have a common difference. Therefore, the given sequence is not in AP. So that's how we do these sums. Very simple. Try to find the difference. If they are same, then they will be in AP. As here it is not same, therefore they will not be in AP. Thrice x and minus x are different, so they are not in AP. Let's move on to question number 2. So the other sums, the remaining sums are also of this type. Very simple, very easy. That's why I am not doing all the sums. So we will move on to question number 2 now, and let's see what the question says in question number 2. So it says here, find the terms mentioned in the bracket of the following sequences. So let's see what to do here. Let me do option D. Okay, question number D. It is given 10, minus 2, minus 14, so on up to we have to find the 9th term. Okay, so we know that to find any term, what is the formula to find the nth term? The formula to find the nth term is Tn, means nth term, is equal to a plus n minus 1 into d, where a is the first term, n is the term number, and d is the common difference. So that means we will need a, n and d in this case. So let's try to find out these three. So here the first term, that is a, is equal to, first term is 10 given in the series sequence itself, 10. What is the common difference? Common difference d will be equal to second term minus first term we can do. So it is minus 2 minus 10, that is minus 12. So we have to find the 9th term, that means we have to find T9. So therefore T9 will be equal to a plus 9 minus 1 into d, n minus 1, so n is 9, so here we will have 9. What is a? A is 10 plus 8 into d, d is minus 12. So it is 10 minus 96, which is minus 86. So the 9th term of this AP is going to be minus 86. So that's how you solve this one. Let's move on to question number 3. What is given in question number 3 is, a few pairs of numbers are given below. Find the arithmetic means as mentioned in the bracket with the pairs. So we have to find the arithmetic mean. So if, for example, we have a sequence of, suppose A, B and C are in AP. If 3 numbers are in AP, then B is called the arithmetic mean of A and C. That means A plus C by 2 will be equal to B. So arithmetic means is just like average of a given series of numbers. Okay, it is just the average. So if you are given two numbers, suppose x and y, and you are asked to find the arithmetic mean of this, that means you have to do x plus y by 2 will give the arithmetic mean. Okay, it is just like every sum of the given values divided by number of values. So here two values are given, sum of the given values divided by number of values. How many values are there? 2, x and y. So divided by 2. Just like you find average, you have to find arithmetic mean as well. So now let's see how to solve this. Let me do question number 7, 3, 7, because it contains some variables x and 9x plus 4. So you are given x and 9x plus 4. These are the two terms given, and you have to find the arithmetic means. How many arithmetic means? You have to find 3 arithmetic means. You have to find 3 arithmetic means between these two. So now that we don't know what are the arithmetic means, we will assume that let A1, A2 and A3 be the 3 arithmetic means between x and 9x plus 4. Okay. So therefore the AP will be of the form, or the AP will be, since these are the arithmetic means this will lie between x and 9x plus 4. Just because I said previously, if A, B and C are in AP, then the arithmetic mean of A and C is B. Okay, so the arithmetic mean lies in the middle of the given two terms. So here also these are the arithmetic means, so these will lie in the middle of these three or these two. Okay, so what will we get? The AP will become x, A1, A2, A3 and 9x plus 4. So now what happens? This becomes the first term and this becomes our, what is the value of this term? First, second, third, fourth, fifth term. So now here A is equal to x and the fifth term T5 is equal to 9x plus 4. So what we can do here is we can write the formula of A plus n minus 1 into d. So it will be A plus 5 minus 1 into d equal to 9x plus 4. So it will be A means the first term. What is the first term here? First term is x. So it is x plus 4d equal to 9x plus 4. So let's have a side change of x. So we will have 4d equal to 9x plus 4 minus x. So we can get from here is 4d is equal to 8x plus 4, right? So d will be equal to 8x plus 4 by 4. So if you take 4 common, it will be twice x plus 1 by 4. 4 will cancel out, so it will be twice x plus 1. So twice x plus 1 is the common difference. So now that you have the common difference, you can find these terms. You add the common difference to x, you get the second term. You add the common difference to second term, you get the third term. You add the common difference to third term, you get the fourth term. So let's do it like that. Let me erase this part. Okay, so these are our terms. So therefore A1 will be equal to x plus the common difference. So what is it? X plus twice x plus 1. So it will be thrice x plus 1. A2 will be equal to A1 plus D. What is A1? A1 is become thrice x plus 1, and with this we will add twice x plus 1, which will be 5x plus 2, right? And A3 will be equal to A2 plus common difference, means this plus the common difference, that is A2 is 5x plus 2, this value plus the common difference twice x plus 1, which becomes 7x plus 3. So that is how we find the arithmetic means. So these are the 3 arithmetic means that we had to insert between x and 9x plus 4. So whatever is the number, if it is given you have to find 5 arithmetic means, then you will do A1, A2, A3, A4, A5 and then the last term. Okay, so as a result you will get the value of the last term. Which term is it? Suppose in this case it is the fifth term. So put the value of A plus n minus 1 into d, find the common difference from here. Once you get the common difference, you can find the arithmetic means one by one by adding the common difference to the previous term. So that's how we do question number 3. Now we will move on to question number 5. Let's see how to do question number 5. So what is given in question number 5? It is given that in an AP, the fourth term is 10 times the first term. Then show that the sixth term is 4 times the second term. So what is given? Number 5, it is given that the fourth term is 10 times the first term, and we have to show that the sixth term will be equal to 4 times the second term. We have to show this T6 equal to 4 times of T2. So it's 10 times of the first term. So let us consider the first term to be x, a. Let the first term be a and the common difference be d. Okay. So now what is given? It is given that T4, the fourth term, is equal to 10 times of the first term. So T4 means a plus 4 minus 1 into d. It is 10 times of a. First term is a, obviously. Okay. So here we get a plus 3d equal to 10a. So if I get a side change now, it will be 3d is equal to 10a minus a. So d will be equal to 9a by 3, which is thrice a. So common difference is thrice a. Now what do I have to prove? I have to prove this. So let us take the LHS first. LHS is T6, which is equal to a plus 6 minus 1 into d. So a is a, okay, whatever, a is a, it is 5d. So a plus 5 into value of d is thrice a. So it is 15a, which is equal to 16a. Let's find the RHS. RHS is 4 times of T2. So it is 4 into a plus 2 minus 1 into d, which is 4 into a plus 2 minus 1 is 1. Value of d is thrice a. Let's put thrice a here. You get 4 into 4a, which is 16a. So as the LHS is equal to RHS, hence we have proved this. So since LHS is equal to RHS, therefore T6 is equal to 4 times of T2, hence proved, or hence showed, whatever you want to write. So hope you understood this one. From here again we found the common difference first. Once we get the common difference, we can put the value of common difference in the given LHS and RHS, and we can get the values to be equal. So that's how we do question number 5. Now we will move on to question number 6, and we will do one of the sums from there. So in question number 6, you have to actually find the sum of a given series. So you know the formula of sum of a given series. The sum of up to n terms is denoted by Sn. Sum up to n terms, the formula is n by 2 twice a plus n minus 1 into d. All the terms are known to you. A is the first term, n is the term number, and d is the common difference. So this is the formula that we will use to find the sum up to a certain number of terms. So let's see what we have to do here. So from question number 6, I will be doing question number 3, and let's see what is the sequence here, what AP is given. So it is given 5n minus 1, there is given 7n, 9n plus 1, 11n plus 2, up to the 27th term. You have to find the sum up to the 27th term, means n is equal to 27. So here what do we have? The first term a is 5n minus 1. The common difference d is second term minus first term, so we can do 7n minus 5n minus 1, which is 7n minus 5n plus 1, which is twice n plus 1. Twice n plus 1 is the common difference, and n is equal to 27. So you have to find, therefore sum up to the 27th term will be equal to 27 by 2 into twice a plus 27 minus 1 into d. N by 2 twice a plus n minus 1 into d. So it is 27 by 2. 2 into a is 5n minus 1 plus 26 into d. D is twice n plus 1. Simplify this and you will get the answer. So it is 27 by 2, and from here let's take 2 common. Okay, if we take 2 common, what happens? This becomes 5n minus 1 and this becomes 13 into twice n plus 1, and the benefit will be, since 2 is common, I can cancel these 2. So I get 27 into 5n minus 1 plus 26n plus 13. So it is 27, 5 plus 26 is 31n plus 12. So now you have to get the multiplication of these two. So it is 27 into 31, 27, and here we will get 81, 7, 3, 8. So it is 837n plus 27 into 12. Plus 324. So this is the 27th term of this AP. Okay, I mean not 27th term, this is the sum up to the 27th term. So if we keep on adding all the terms up to the 27th term, this is the value that we are going to get. Okay, so now let us move on to question number 7. I am doing one sum of each type so that you get the idea and you can solve the others. There is no use of doing all these sums because they are all of the same type. That's why I am doing one from each. Okay, let's move on to question number 7, and here it is a bit different. It is said that if A, B and C are in AP, then prove that the following terms are also in AP. So I am going to do question number 2. It is given here A into 1 by B plus 1 by C, B into 1 by C plus 1 by A, and C into 1 by A plus 1 by B. We have to prove that these three terms are also in AP if A, B and C are in AP. So we have to prove that these three are in AP. Now what is given is that A, B, C are in AP. If A, B, C are in AP, that means what? That means the common difference will be same. So we can write B minus A will be equal to C minus B, right? From here we can get that if we do some side change, if B comes to this side, it is going to B plus B is equal to A plus C, which means twice B is equal to A plus C. So we can use the values given here to our need. Now if we have to prove that these are in AP, then we have to prove that their common difference is also same. So we can write here that to prove this, that is, what do we actually have to prove? We have to prove that the common difference is same. That means we have to prove difference of these two and difference of these two should be equal. So we will write that is B into 1 by C plus 1 by A minus A into 1 by B plus 1 by C must be equal to C into 1 by A plus 1 by B minus B into 1 by C plus 1 by A. This is what we actually have to prove. The common difference of these two, difference of these two and the difference of these two. We have to show that they have a common difference. So now we will take LHS, means this part. So it is B into 1 by C plus 1 by A minus A into 1 by B plus 1 by C. So what do we get from here? We get A plus C by AC minus A into B plus C by BC. So it is AB plus BC by AC minus AB plus AC by BC. Take the LCM as ABC, and what we get from here is AB plus BC whole into B, and from here because of the LCM we get A into AB plus AC. Now let us keep on simplifying it. We will get AB square plus B square C minus A square B minus A square C. So we have here ABC. What is the next thing that we can do? What we can do here is let's take A square common. Here we have A square. From here we can get see A square B and AB square and A square B. From these two we can take, okay, let's put these two together. AB square minus A square B plus B square C minus A square C, and we will get ABC. AB, so we can take AB common, we will have B minus A. Plus from here we can take C common, so it will be B square minus A square by ABC, right? So what we get from here is AB into B minus A plus C into B plus A into B minus A, because it is A square minus B square formula, again ABC. So B minus A can be taken as common, and what we have from here is AB plus this into this. So C into B is BC, C into A is AC by ABC. Okay, so let's keep it like this, and let's move on to the RHS. In RHS we have this C into 1 by A plus 1 by B minus B into 1 by C plus 1 by A, right? So what we get from here is C A plus B by AB minus B into C plus A by CA, exactly the same process. So we get AC plus BC by AB minus BC plus AB by CA. Take the LCM ABC, this will be multiplied by C because of the LCM, and this will be multiplied by B, and what we get from here is AC square plus BC square minus B square C minus AB square by ABC. Okay, again we will take AC and BC will take common. So from BC square minus BC, if we take BC common, we will get C square minus C minus B, and from here we can get these two, AC square and AB square. If I take A common, it will be C square minus B square, okay, and here it will be ABC. So let me take again the same process, C minus B plus A into C plus B into C minus B by ABC. Alright, from here we will take C minus B common. If I take C minus B, I am left with BC plus AC plus AB by ABC. Now from here if you check it out, B minus A and C minus B are equal. So in place of C minus B, I can write B minus A into AB plus BC plus CA by ABC. So see, the LHS and the RHS are now equal. So since LHS equal to RHS, therefore these three terms will be in AP. So hope you understood how to do this. Keep on simplifying, you will get a value, and same keep on simplifying the right hand side, you will get another value. You can use this thing at one point of time in one of the proof that you are doing. At one place or the other, you will get a chance to use these values so that you can prove them to be equal. So I hope you understood how to do this. Let's move on to the next one. So we are going to go to question number 9. Question number 8, why I am skipping question number 8 is because it is almost similar to question number 7, this sort of proof. So if you can do the sums from question number 7, you will be able to do question number 8 as well. Okay, so let's move on to question number 9 and see what we have to prove in that. So in question number 9, it says that if A, B, C are in AP, then find the arithmetic means of the following pairs. You have to find the arithmetic mean, and I am going to do question number 3 from Roman 3 from question number 9. So in Roman 9, the question number 9 is given that A, B, C are in AP. So if A, B, C are in AP, that means what we will get? We will get B minus A is equal to C minus B, just like the previous one. It's common, they will have a common difference. Difference of B and A and difference of C and B must be equal. So here if we do side change, we are going to get 2i's B is equal to A plus C. This is what we know we are going to get. Sorry for that. Okay. So now what we need to do? We need to find the arithmetic means. So therefore, the arithmetic mean of which one you have to find? A into B plus C by ABC and C into A plus B by AB is equal to. So the arithmetic mean, what will be the arithmetic mean? Arithmetic mean, as I have said, if you have two terms A and B, the arithmetic mean of A and B will be A plus B by 2. So you have to add these two and divide it by 2. That's how you get the arithmetic mean of two numbers. So what we have to do? We have to do A into B plus C by BC plus C into A plus B by AB whole divided by 2. That's how you get the arithmetic mean. So let's take the LCM first. It will be obviously ABC, and here you have to multiply it with A. So it will be A square into B plus C, and this will be C square into A plus B by ABC by 2. So now ABC will come down, it will be twice ABC, and what we get from here is A square B plus A square C plus C square A plus C square B. So again, from here we can take some common, A square C and C square, we can take AC common, it will be A plus C, and from here we can take a B common, so it will be A square plus C square by twice AB C. So what we can do now is keep AC as AC and A plus C same plus B into, what changes we can bring to this is A plus C, A square plus C square can be written as A plus C whole square minus twice AC, it will give us A square plus C square by twice ABC. Okay, so now A plus C can be written as twice B. So in AC into twice B we can write, okay, plus B into A plus C is again twice B. So we can write twice B whole square minus twice AC by twice ABC. So it becomes 2 into ABC if we break the bracket plus B into, this becomes 4B square minus twice AC, twice ABC, twice ABC plus, what can we write here? We can write 4B cube, I am breaking the bracket, so it will be 4 into 4B square, B into 4B square gives 4B cube, and B into twice AC is twice ABC by twice ABC. So twice ABC cancels out, what we can write from here is 4b cube by twice ABC. So 2. So from here what we can do, we can write twice b, and this b and cube will cancel out to become square. So what we get here is twice b square by AC. Cool. Next what we do, we will write it b into twice b by AC. Why we did this? In place of b or twice b, I can write, what can I write in place of twice b? In place of twice b, I can write a plus c by AC. Now why have I done this? Even if I had kept it up to here, it would have been correct. Why I did this? Just to put it in a sequence with what is given. See, it is a into b plus c by BC, c into a plus b by AB, b into a plus c by AC. So now it makes more sense. So it looks better. It comes in like a symmetry to what is given. That's why I did this. Even if you keep it up to here, it will be correct. So this is the arithmetic mean between these two numbers. So hope you got it. You don't have to do anything. From here you get twice b equal to a plus c. The numbers that you have, add them, divide it by 2 and you get the arithmetic mean. Okay. Let's move on to question number 11. I am going to do question number 11 next. Okay. So what we have in an AP is, so AP is given, it is minus 9, minus 6, minus 3 dot dot dot. This is the AP. How many terms of the AP are to be added to get a sum of 66? So SN is also given. AP is this. SN is equal to 66. Yes, SN is 66. So here, what is the first term? First term is 9. What is the common difference? Second term minus first term. Minus 6 minus of minus 9. That is minus 6 plus 9, which is 3. Now, we have to find how many terms we have to add. Means we have to find n. So let the required number of terms be n. Therefore, Sn is equal to 66. So it is n by 2 twice a plus n minus 1 into d is equal to 66. So it is n by 2. I don't know what is the value of n, but I know the value of a. A is minus 9 plus n minus 1 into d is 3 equal to 66. So it is, I can keep n here. It is minus 18 plus thrice n minus 3. 2 goes to that side, becomes 132. So now if I break, okay, let me simplify it even further. Minus 21 plus thrice n is equal to 132. So if I break the bracket now, n into thrice n gives thrice n square. N into minus 21 is minus 21 is equal to 132. Let's bring all these. Let's take 3 common. It becomes n square minus 7 equal to 132. So n square minus 7 is now 132 by 3 is equal to, this is 44. So n square minus 7 minus, sorry, minus 7n. I think it will minus 7n. Yes, this is going to be n minus 7n minus 44 is equal to 0. So what can we do here? We have to do middle term factorization. So we can write this as 11 minus 4. 11 minus 4 is 7. 11 into 4 is 44. Because of the minus sign, it is minus. Minus 44 equal to 0. So n square minus 11n plus 4n minus 44 equal to 0. So n into n minus 11 plus 4 into n minus 11 equals 0. So it is n minus 11 into n plus 4 equals 0. So either n will be equal to 11 or n will be equal to minus 4. Now negative is not possible because you cannot have minus number of terms. You cannot have minus 4 terms in an AP. So number of terms is always positive. So this is not possible. Therefore, required number of terms is 11. Okay, very simple. Almost all the values are given. You have to only find n. It is like solving a linear quadratic equation. Just like solving a quadratic equation, you have to solve this. Okay, so hope you have the idea of this now. Let's move on to our next sum, and we will be doing question number 14 now. 14. So in question number 14 is a different sort of series because it seems different. Yeah, and sum is also a bit of different. So let's look into that. Question number 14. It is the given series is, or the given AP is 85 square minus 83 square plus 84 square minus 82 square plus 83 square minus 81 square plus 82 square minus 80 square and up to the 30 terms. Okay, you have to find the sum of 30th term. Okay. So, you have to find the sum up to the 30th term, right? So, here, so let us find the sum. Therefore, S30 will be equal to, we will not use the formula this time, not right away, but we will use the formula, but let us check it in a different way. 85 square minus 83 square plus 84 square minus 82 square plus 83 square minus 81 square plus 82 square minus 80 square plus, what we will do here, we will make pairs, these two, these two, these two and these two. Okay. So, up to the 30th term, or we can write up to 30 terms. We have to find the sum of 30 terms. So, this is like a square minus b square. So, what we can write here is 85 plus 83 into 85 minus 83. Similarly, we can write this as 84 plus 82, 84 minus 82 plus 83 minus 8 plus 81, 83 minus 81 plus 82 plus 80, 82 minus 80. But this time what happens? The sum continues up to, how many terms were there? 1, 2, 3, 4, 5, 6, 7, 8 terms were there, right? Now if you check the term, this has become a product. So product is a single term. So this is 1 term, 2 term, 3 terms and 4 terms. So 8 terms have converted to 4 terms because we have made them products. That means 30 terms will also reduce to half of that. 8 has converted to 4, so 30 will reduce to 15 terms. Okay. So what is the value here? It is 85 plus 83. So it is 8 and 16, 168 into 2 plus this is 166 into 2 plus 164 into 2 plus 162 into 2 plus up to 15 terms. So this is 16, 336, 332 plus 328 plus 324 up to 15 terms. So now we will use the formula. This is the first term. What is the common difference? The common difference is minus 4. See, the values are decreasing. So common difference 332 minus 336 is minus 4. So here we can write the formula of the sum up to n terms. And what is the n terms here? 15. So it will be n by 2, 15 by 2, twice a. What is a? 336 plus n minus 1, 15 minus 1 into d. d is minus 4. Okay, I hope you understood what I wrote here. 15 terms, so n will be 15 by 2. Twice a is the first term plus n minus 1, n is 15, so 15 minus 1 into d. d is common difference. Common difference is second term minus first term. 332 minus 336 is minus 4. So now let's find the value. So this will be 12, 1, 3, 6, 7, 672 plus 14 into minus 4. So it is 15 by 2, 672 minus 56. So it is 15 by 2 into 72 equal 22, 616. We will get 308. So the value is 15 into 308. So let's find the value. 308 into 15, that is 40, 15, 308, 0, 12, 6, 4, 4, 6, 2, 0. This is the value of the sum of this series up to the 30th term. So if you add, keep on adding the 30 terms, you will get the value 4620. So I hope that's clear. Let's move on to the next question, and this time we will be doing question number 17, 17. And what we have here, the sum of 4 consecutive integers in an AP is 32 and the sum of their squares is 276. Find the terms. So we have to use a little bit of different technique here so that it becomes easier for us to find the terms. So it is said that sum of 4 consecutive terms in an AP is 32. So we have to consider 4 consecutive terms. So this is question number 17. So we will say let 4 consecutive terms in an AP be, see what I write here. I will write a minus 3d, a minus d, a plus d and a plus 3d. This can be done. That means what do I get here? The first term is this. What is the common difference? The common difference is 2d. So if you add, just for example, if you add 2d to this, you will get a minus d. If you add 2d to this one, you will get a plus d. If you add 2d to this one, d becomes thrice d. That means we have a common difference of 2d. Okay. So these are the terms that we have taken, 4 consecutive terms, but the common difference is 2d. First term is a minus thrice d. Now according to question, sum of these terms is means a minus thrice d plus a minus d plus a plus d plus a plus thrice d. Sum of these terms is given as 32. 32. Why have I done this? If you look carefully, let me remove the brackets. Minus thrice d minus thrice d minus d minus plus d will cancel. I will have 4 a's. 4a equal to 32. So a becomes 32 by 4, that is 8. I directly get the first term. Now I will use the second condition and I will find the common difference. So the common difference to find, it is given that the sum of their squares is 276. Also sum of the squares of all this. So a minus thrice d whole square plus a minus d whole square plus a plus d whole square plus a minus thrice d whole square is equal to 276. So a plus b whole square and a minus b whole square is equal to a square plus b, twice of a square plus b square. Let me show you how. A plus b whole square and a minus b whole square, if I do this, what do I get? A square plus twice ab plus b square plus a square minus twice ab plus b square. So this will cancel out. It will be twice a square plus twice b square, which is twice of a square plus b square, right? So it is twice of a square plus b square. So a minus thrice d whole square plus, this should be plus a plus thrice d whole square, if I write this together, and a minus d whole square plus a plus d whole square is equal to 276. A minus b whole square, a plus b whole square, so it is twice of a square plus b square. This is also twice of a square plus d square equal to 276. Okay, what is the value of a? The value of a is 8. So 8 square plus 9d square plus twice of 8 square plus d square is equal to 276. Let's solve it here. So it is 2 into 64 plus 9d square plus 2 into 64 plus d square is equal to 276. So it is 128 plus 18d square plus 128 plus twice d square is equal to 276. So 128 plus 128 is 256 plus 20d square is equal to 276. So 20d square is equal to 276 minus 256, which is 20. So d square will be equal to 20 by 20. So d square equal to 1, which implies d is equal to plus minus root over 1, that is d is plus minus 1. So the common difference will either be minus 1 or plus 1. So what will be the AP? We have to find the terms in the AP. So hope you understood this one. Let's erase a part of it. So therefore the terms will be if d is equal to plus 1, then the first one is a minus thrice d. So it will be 8 minus 3 into 1, 8 minus 1, 8 plus 1 and 8 plus 3 into 1. So it will be 8 minus 3 into 1, that is 5, this will be 7, this will be 9, and this will be 11. Okay, and now if the common difference is, if d is equal to -1, then what will happen? Then it will be 8 minus 3 into -1, 8 minus -1, 8 plus -1, and 8 plus 3 into -1, which will be 8 plus 3, 11, 9, 7, 5. Okay, so that's how you find the AP that is required. So we move on to our last sum, that is question number 20, and we will end the video up to this. So let's start question number 20 and try to solve that one. So what is it given in question number 20? It is said that the ratio of the sum of n terms of two arithmetic progressions is 7n plus 1 is to 4n plus 27. Find the ratio of the 11th term. So what do we have to do? Very simple sum. Question number 20. What we have to do is, it is given ratio of two APs, ratio of sum of two APs is equal to 7n plus 1 is to 4n plus 27. You have to find the ratio of the 11th terms. So let us consider the two APs like this. Also, it will be sum up to n terms of first AP by sum up to n terms of second AP is equal to 7n plus 1 by 4n plus 27, right? So let us write, we know the formula, it is n by 2, twice a1, because it is the first AP, let us give it a1 plus n minus 1 into d1, and let it be n by 2, twice a2 plus n minus 1 into d2 is equal to 7n plus 1 by 4n plus 27. These two will cancel out and we will get twice a1 plus n minus 1 into d1 and twice a2 plus n minus 1 into d2 is equal to 7n plus 1 by 4n plus 27. So this is what we need to, this is what we get from the given values. Now what we need to find is the ratio of the 11th term of both the APs. 11th term, not sum, 11th term. What is the formula of 11th term? Is a plus 11 minus 1 into d, not twice a, because twice a is for sum. So now we need to convert this value into a plus 11 minus 1 into d1 and a2 plus 11 minus 1 into d2. So we need to remove this 2 and we need to bring in n as the value of 10. So how do we do this? So we have to find the sum up to the 11th term. So therefore, what value of n should you take right now? How to understand what value of n should I take so that I can simplify it to get a plus 11 minus 1 into d. So to do this, you always, what you need to remember, you multiply 11 by 2 and subtract 1 from it. So 11 into 2 is 22, minus 1 is 21. So now just put 21 here and see what happens. So therefore, or now what we can do, okay, let me continue it here. So now what we will do, we will put the value of n as 21. So what we get is twice a1 plus 21 minus 1 into d1 and twice a2 plus 21 minus 1 into d2 is equal to 7 into 21 plus 1, it is 4 into 21 plus 27. Okay. So what we get from here is, this becomes twice a1 plus 20 d1, this twice a2 plus 20 d2 is equal to, this is 7 plus 1, this is 84 plus 27. So we can get 2 common from here and we can write a1 plus 10 d1, 2 common, a2 plus 10 d2 and we will get 148 by 111. So we cancel these two. 37 into 3, 37 into 4. So now see, I can write this as a1 plus 11 minus 1 into d, a2 plus 11 minus 1 into d2 is equal to 4 by 3. That means this is the 11th term, a plus n minus 1 into d. So a plus 11 minus 1 into d means this is the 11th term of first AP by this is the 11th term of second AP, and the value is, or ratio is 4 by 3. So in order to get this 11 minus 1 factor or 11 minus 1 value, this is 10, what we have to do is we have to pre-assume this here. The what value of n should I take so that I can get this 11 minus 1 factor here? Remove the 2, because these 2 needs to be removed, because we don't need twice a, we need a. So we need to remove the 2 and we need to get 11 minus 1 here. So what should you do when you are in this situation? You take the number of terms you need, multiply it by 2 and subtract it by 1 and put the value of n that way. The value of n that you should take here should be twice of this term minus 1 always. Okay, when you have this sort of situation, it is the easiest way to find out what value should you take in place of n so that you can convert it to this form. Okay, so it is always 2 into the number of terms minus 1. So that is how you solve up to question number 20. I hope you understood all these sums. If you have any confusion, make sure you ask me in the comment section. I will be there to help you out. So thank you everyone for watching, and until next time, cheers.